Valves play a large role in any processing industry. Many chemical and food processes consist largely of valves and piping. To give you an example, the valves and piping in a typical hydrocarbon processing plant represents 22% of the total capital expenditure. The next largest cost is for vessels at a mere 15%. Valves are available in a variety of sizes. From those that can be held in the palm of your hand, to those that are man-sized and must be handled by cranes. They are manufactured in a wide variety of materials, such as plastics, iron, brass, bronze, special alloys, steel, and stainless. There is a wide variety of designs, and valves come equipped with flange joints, welded joints, and threaded joints. This last valve is a gate valve and is used for on-off service. This type or style of valve is used more frequently than any other. When fully open, gate valves allow the flow to pass straight through with approximately the same diameter as the piping, and hence they have very low pressure drops. Gate valves are available in various designs, some with rising stems, others with non-rising stems, a variety of gate, disc, or wedge designs, and several different types of seating arrangements. Generally speaking, gate valves are heavy and require a large space for installation. The gate valve should never be used for throttling service. This would tend to erode the disc and seat, and eventually the valve would not shut off tightly. Another valve commonly used in on-off service is the plug valve, or an adaptation of this valve, the ball valve. The ball or plug turns. In the fully open position, the flow is straight through, and hence there is a low pressure drop. An important feature of the plug valve is its easy adaptation to multi-port construction. 3- and 4-way valves are available. The action of a plug valve is the same as a stopcock on a burette. The compact nature of the valve offers lighter weight and considerably less room for installation when compared to the equivalent gate valve. For throttling service, the globe valve is normally used. There is a wide variety of designs. The weight and space requirements are about the same as gate valves. The construction of the globe valve is such that it is usually unidirectional, and as the fluid passes through the valve, a change in direction of flow is required. The needle valve is a special design of the globe valve, in which the movable disc is tapered or needle-shaped. This is an excellent valve for the fine adjustment sometimes required in throttling service. Due to the change in direction of flow, gate valves have a high pressure loss. An attempt to lower this pressure drop has been made by the design of an angle valve. Because of their throttling action, globe valves are usually used for control purposes. This pneumatically operated valve is a double-seated globe valve. The globe valve may also be used for rapid changes in flow rate, such as this fast-acting valve. A pull on the lever can change the valve from fully closed to fully open. One valve that is good for both on-off and throttling service is the butterfly valve. This design is the same as the damper in a stovepipe. The disc or flow control element has about the same diameter as the connecting pipe, and thus there is low frictional losses, and hence low pressure drop. Butterfly valves are suited to large flows of gases or liquids at relatively low pressures. A study of the flow lines through the valve shows that butterfly valves are a good selection for slurries, or liquids with large amounts of suspended matter. The flow does not permit sediment to build up. Butterfly valves are fast-acting, as a quarter turn can change the disc position from fully open to fully closed. The Saunders valve is the most widely used of the diaphragm valves, although designs similar to a pinch clamp on a rubber tube are available. As can be seen from the flow lines in the valve illustrated, diaphragm valves are suitable for throttling service. A wide variety of flows is possible. Such valves are good for handling viscous media, slurries, or corrosive fluids. The check valve is used solely to prevent the reversal of flow in a piping system. They are unidirectional in their flow. The one illustrated requires flow from left to right. The flow causes the disc to pivot on the hinge and allows the flow to pass through. Any reversal of flow would cause the disc to fall back against the seat and stop the flow. There are several different designs of check valves. This has been a brief overview of valves, their characteristics and uses. For a more detailed discussion, consult the literature supplied by the valve manufacturers, magazine articles, and the handbooks.